This is the Chapter 5 test review for Algebra 1A, and this is a longer review, so I will probably split this into multiple videos. So this video will cover the first part, and then we'll pick up with another video, later on in the packet. So starting with number 1, Nashville is 500 miles away. Atlanta is further away than Nashville, but less than 800 miles away. Write a compound inequality. So just to remind you, a compound inequality is when we're kind of combining two inequality statements in one. All right, typically that's one of those sandwich ones where it's like the number is larger than this but smaller than this, which is exactly what we have going on here. Atlanta needs to be larger than 500 miles away but smaller than 800 miles away. Okay, so I'm going to write this like this. 500 is less than, let's just use A for Atlanta, and that's going to be less than 800 miles away. And essentially what we're saying here is that Atlanta is somewhere between 500 and 800 miles away. We know it's more than 5. We know it's less than 8. Okay? On a number line, I really am okay with you just kind of putting these numbers on here anywhere because, like I said, I'm not concerned about whether or not you know how to count. All right? These do not have equal bars, which matches kind of the wording in the problems up here. So I'm going to use open circles to show 500 to 800 and then shade everything in between. Okay, this represents the distance to Atlanta. Okay. Okay, looking at number 2, and I've got a nice pretty color picture here. I know your packet is black and white, but I think you can still see what's going on. It says estimate the solutions. I just want to remind you that the solutions are, excuse me, the points where the graph intersects. Okay, so we have one solution here and one solution here that we're looking for. And it is okay to just approximate here. I didn't give you the equations or anything, so you really don't have a way to find these exactly. I will point out that for this to be a 10, this must be counting by 2's, okay? You might not catch that on your own, but so this is about halfway between these two lines here, and so I would call that about a -3 if we're counting by 2's. There's -2, there's -4, so -3. So one of my solutions I'm going to say is -3, 0. The other one, this one, I would say this is at about 4, 2-ish if I was just rounding to nice happy whole numbers. Okay, it's a little bit more than 2, I think, but I'm just going to label those on here. So this would be -3, 0. This would be 4, 2. Okay. Okay. Difference between consistent and inconsistent. Essentially, consistent means there's a solution of some kind. Inconsistent means no solution. So a consistent graph, let's see, let me draw some graph lines in here. A consistent graph might be something real basic where you just have two lines that cross each other. So one line here, let's say, and another line here. Okay, and so there's a solution right there in the center. Or it could be something like let's see, we could have a hyperbola maybe with a line that comes through like this. And so there's our solutions here and here. Okay. So consistent is just anything with a solution. Inconsistent, if we're talking just lines, just straight up linear equations, the only way to have no solution is to have parallel lines. Okay, so if I have a line kind of running this way and a line running this way, that's no solution because those don't cross. It is possible to get no solution with curves, with something like this. So for example, sorry, I'm getting my colors mixed up here. So you could have something like a parabola here and a line that comes down like this, where that line is never going to intersect the parabola. Okay, that would also be no solution, and we would call that an inconsistent system. Okay. By the way, over here with this one, you can also have that situation where the two lines are like laying on top of each other. Okay, so if you had one line on top of the other, that would also be consistent. There would just be an infinite number of solutions. Okay, number 4 is back to our old friends, the systems, right? Substitution or elimination here. You can pick which one you like better. This one wouldn't be bad to do either way. Elimination could work really well. Look, these x's are almost ready to cancel out if I just make one negative. Or it wouldn't be hard to get like that x up on the top by itself and do substitution either. So whichever you prefer, I'm going to go with elimination. And I'm going to make the entire top equation negative. So I'm going to make that a negative x. That's really going to make that a plus 7y, and that's going to make this a negative 38. Okay? But again, I just want to clarify there would be other ways to do this. So when I add the equations together, negative x and positive x are going to cancel. 7y plus 14y is 21y. And negative 38 plus negative 46, man, I'm testing my mental math here today, but that's going to be negative 84. Okay. And then to solve from there, I'm going to divide by 21. Divide by 21. Okay. And I end up with y equals negative 4. And then I'm going to plug that back in to solve. It doesn't matter which equation you use. Because I've messed this one up a little bit, I think I'll use that second equation there. So now I'm going to take this and plug it in x plus 14 times negative 4 equals negative 46. So we end up with x that's going to be a negative 56 equals negative 46. And then if I add that 56 to both sides, I end up with x equal to positive 10. And so my solution here that I would write as my final answer is 10 comma negative 4. And remember, these systems are really easy to check your work for, especially if you've got a calculator handy. You could do this all in your calculator without even having to write any of this down. But so if I wanted to check my work here in this first equation, I would say 10 minus 7 times negative 4 and make sure it equals 38. It does. And then in the second equation, I would say 10 plus 14 times negative 4. And it should equal negative 46. And it does. So that's how I know that I have the right answers. Okay, let's keep going here. The back here. Okay, so this one is you've seen this situation before. We're looking at car rentals, and there's a flat rate and a rate per day and da-da-da-da-da. I think the interesting part about this problem is we're looking to see when is no rush less expensive than speedy car rentals. This is an inequality, okay, whether you recognize it for that or not at the beginning. We are going to write this like an inequality. So I'm going to work through it like an inequality. Some of you are going to fight me and say we could just write this as an equation. I'll make a point about that at the very end. So try to stick with me here. I want to know when will no rush be less expensive than speedy car. So I'm going to start with no rush. They have a flat rate of $2.75 and $20 per day. So for no rush, I would say, I forgot my numbers now, $2.75 and then plus $20 a day. And I want to know when will this be less than speedy car rentals, which is $150 and an additional $50 a day. Okay, so this expression right here represents no rush. This expression right here represents speedy car. Okay, and I want to know when will no rush be less expensive than speedy car. So to solve this, I would probably personally start by subtracting 20d from each side. That leaves us with this gone. So I have 275 is less than 150 plus 30d. Keep going over here. From there, I would probably subtract 150 on each side. I'm going to try to squeeze that in. So minus 150 minus 150. Let's see, 275 minus 150 is going to be 125. So 125 is less than 30d. Let's divide by 30 on each side. 125, whoops, 125 divided by 30. Sorry, can't see what I'm doing. 125 divided by 30 is, nope, not plus. Okay, so this is what I get mathematically. 4.16 repeating is less than D. So if I think about this from the perspective of D, D must be larger than 4.16. Now we know that if we're talking about numbers of days, 4.16 doesn't really make a whole lot of sense, right? So if I need to be larger than this number, really I need to be 5 or greater. Does that make sense? So if D is greater than 4.16, if I'm reading this thing backwards, 4 is not going to cut it, okay? 4 days is not enough. It's got to be more than 4. So I would answer this as D is greater than or equal to 5 as my final answer, okay? And so here's the thing, that the reason I made such a big deal about this as an inequality, because there are going to be plenty of you who set this up as an equation and you find what value will make these two things equal to each other. And you'll find this same thing. You'll find 4.16. But then the question is, which side of that 4.16 do you want to be on? Because 4.16 is not the answer to how do you be less expensive. Okay, that's when you're the equal expensive. That was a terrible sentence. I'm so sorry about that. But that's when your expenses will be equal. Okay, that's when the two companies will cost the exact same amount. I don't care about where they cost the exact same. I want to know how many days would I have to rent this car for to make this extra expensive $275 at the front worth it, right? And so you want to make sure you're not just saying 4.16 or 5. It's anything above 5. It's 5 and beyond, okay? And so that's why I would recommend you just set it up as an inequality to begin with, because otherwise when you get to this answer, you're going to have to do some thinking to figure out which side of that number do you actually want to be on, okay? Okay, onward. Off my soapbox on that one. Number 6, solve this inequality, and this one has a major minefield of negatives here. This negative sign here, be really careful with this. This needs to distribute to both these numbers in here, because when you're thinking about this, this is really saying we want to do 6 minus 4, but then we also want to subtract the 2x. So that minus sign says I'm subtracting both of the things inside those parentheses. And that has to be greater than 10. Okay. I can go ahead and put the 6 minus 4 together and get 2 minus 2x is greater than 10. From here, I would probably subtract the 2 from each side. And I'll just carry on over here. So this is gone. Now I have negative 2x is greater than 8. Now from here, I'm going to divide by negative 2. And because I'm dividing by a negative 2, I need to think about that inequality symbol, right? I'm dividing by a negative, so when I write my final answer here, I'm going to say x has to be less than negative 4. On my number line, I'm going to throw the negative 4 on there somewhere. This is going to be an open circle, and I want to make sure that I'm shading to the left. I always have a hard time shading in the left direction, but okay. This is what your number line should look like. If you want to check and make sure that you're correct, okay, because if you're nervous about, hey, did I screw up those negatives or something like that, choose something from down here in this shaded area. Think about what would be this direction from negative 4. And be careful to think about how negatives work. So like this would be maybe, I don't know, negative 7, let's say. So I can test this by plugging negative 7 into my original inequality here and seeing if it works. I'm trying to put the calculator where you can see it. There we go. So 6 minus, parentheses, 4 plus 2 times negative 7. And I'm looking for something to be bigger than 10, okay? And I get 16. So this value worked, and that was a good way for us to verify that we shaded in the right direction with all those negative signs and everything, okay? So like I said, just be careful about that, that you want to make sure you keep track of those negatives and what they do to your inequality. Okay, number 7 is a system of 3 equations, which is triple the fun. But the nice thing is these 2 equations are already set up really nicely for substitution. I have what z equals that I can put in right here, right? And I have what y equals, which I can put in right here. Okay, So if I were to rewrite that top equation now, it's going to look like this. 4x plus 2, but then in place of y, I'm putting 4x minus 5. Okay. Minus, now be careful with this. See that minus z? I want to make sure I'm subtracting this entire thing as my z value. So even though there's no number in front of it, I'm going to put it in parentheses, and that's going to make a huge difference. If you got this one wrong, I would almost guarantee this is the mistake that you made. Okay, and then we're going to have this thing equal to 8. So when I go to solve this now, I'm going to distribute this 2 here. Over here, I'm going to distribute this negative sign. So I end up with 4x plus 8x minus 10. And then here, when I do minus negative 7, that's really just going to be a plus 7x. And then this negative applied to that 1 is a minus 1. Okay. I'm going to combine my x's, so 4x, 8x, and 7x. And those are all on the same side of the equals, so I can just kind of smash them together. That's 12 plus 7, which is 19. And then I'm also going to put together my negative 10 and my negative 1. So that's negative 11. Still equals 8. Now this is a much easier equation to solve, right? I'm going to add 11, and this leaves me with 19x equals 19, which when I divide, I end up with x equals 1. Okay, so that's part of my solution. I do still need to go back and find y and z. So once I have found that x equals 1, I'm going to go right back up here to where I have my equation for z and y, and I'm going to plug it in. So z equals negative 7 times 1 plus 1. That's going to be negative 6. And then my y is 4x, minus 5. That's 4 minus 5, so y is negative 1. Okay, so you would have to have all 3 of these values to have solved the system correctly. Okay, and again, we could check this using that first equation would probably be the easiest way. Technically, should we check it in all 3? Yes. But if we just wanted to real quick check and see that we got everything right, let's see, 4 times my x value, which is 1, plus 2 times my y value, which is negative 1, minus my z value, which is negative 6. And I'm hoping this comes out to be 8. Voila. Okay, we got that one right. Okay, let's look at number 8, and then I will probably cut off this video and pick up with the rest of it in a second video. Graph the solution set. When we are graphing anything with an inequality, meaning a greater than or a less than, there's going to be some shading, okay? So I'm going to start at positive 3 on the y-axis. There's that point right there. And then slope is 2 over 1. So that's telling me to go up 2 and over 1, up 2 and over 1. I could also go down 2 into the left 1 with a 2 over 1. There's no equal bar here, so I want to make sure I'm not including the line as part of my solution set. So I'm going to use a dotted line to represent that. Okay, so dotted line there. And y is less than means we're heading downward, right? So underneath the line is where we want to shade. So all of this is going to get shaded. Okay? So when it says identify 2 points that satisfy the inequality, anything up here, anything up here is not going to satisfy the inequality. Anything on the line is not going to satisfy the inequality because it's a dotted line. So I want to be picking from things that are shaded here. So I'm just going to pick a random 2 points. I'm going to pick maybe this point and this point. And again, I just picked those totally at random. And so this point here is 1, 2, 3, 4, 5, and then up 2. So just as a possible answer, 5, 2. This point here looks like 1 and 1, 2, 3, 4, 5, 6, 7, 8. I hope I counted that right, but 1, -8 would work as well. Okay, or anything else that's shaded. Okay, and I should probably make a note of that in case you're watching this and making sure you got your answers right. Anything else that falls in that shaded area is fair game. Okay, all right, that does it for that first page of your review. Like I said, we'll pick up with the second part of the video in just a little bit.